Good morning. Today we will discuss aromatic heterocycles in M.sc final chemistry. In previous class we discussed some criteria of heterocycles, that is structural criteria. Structural criteria is of two types. First is bond length. Another is dipole moment. Today we will discuss energetic criteria. The first point is delocalization of energy. Due to delocalization of pi electrons, all the 6 carbon-carbon bonds becomes same. The pi electrons are spread over all the 6 carbon atoms in benzene. The delocalization of pi electrons is held responsible for greater stability of benzene. Thus, delocalization energy can be defined as the additional bonding energy obtained as a consequence of delocalization of pi electrons, which initially belong to the isolated double bonds. For the determination of delocalization energy, following assumptions are made in the Huckel molecular orbital treatment. First is, since sigma and pi electrons are in planes perpendicular to each other, hence pi electrons in a conjugated system do not interact with sigma electrons. The complete molecular wavelength can be expressed as sigma m is equal to sigma plus pi. Total pi electron wave function psi pi is a single product of one electron function, and the total energy of the pi electrons is taken as the sum of one electron energies. For a system containing n pi electrons in the ground state, the molecular wave function is the energy can be expressed as in a pi molecular orbital in terms of two parameters. First is Coulomb integral. It is symbolized by the alpha. It represents the average energy of an electron in an isolated p orbital before overlapping. All such integrals are equal. Second point is resonance integral. It is given the symbol beta. It represents the energy of interaction between two atomic orbitals. It denotes the energy of stabilization obtained due to pi orbital overlapping. For atoms that are directly bonded, the beta has some finite value, but for atoms that are not directly bonded, beta has no value. The energy of pi electrons can be calculated by using alpha and beta parameters. Thus, the total energy of 6 pi electron in benzene residing. Since the energy of 2 pi electrons in ethane molecule is 2 alpha plus 2 beta, hence the energy of 6 pi electrons in 3 isolated double bond is equal to the 2 beta. The pi electron arrangement of benzene gives more stability by the energy amount 2 beta. Since this is associated with the delocalization of 6 pi electrons, therefore it is termed as the delocalization energy of benzene. The delocalization energy for pyridine and other heterocyclic compounds will have the same value as that for the benzene, that is 2 beta, because pyridine containing nitrogen as benzene atom is believed to be derived from benzene by the replacement of CH group by nitrogen atom. Since nitrogen is more electronegative than carbon, presence of nitrogen in pyridine results in unequal distribution of pi electron density. Delocalization energy for heterocyclic compounds. First is benzene. Total pi energy is 8.000. Second is pyridine. Total pi energy is 7.249. Alpha pyron. Total pi energy is 7.081. Gamma pyron 6.999. Thiophene 5.186. Furan 4.598. Second is empirical resonance energy. Due to delocalization of pi electrons, molecules show increased stability. Hence, the difference between the experimental value of heat of formation and the calculated value of hypothetical structure is known as empirical resonance energy. Another definition of empirical resonance energy can be given as the difference between the energy of the real delocalized structure and the energy of the hypothetical localized structure. The empirical resonance energy is made up of two energy terms. First is distortion energy, second is vertical resonance energy. Distortion energy. The distortion energy corresponds to the energy required for single bond compression and to stretch the double bond. Second is vertical resonance energy. Vertical resonance energy can be defined as the difference between the energy of the resonance hybrid and the energy of one of the resonating structures which contributes most to the resonance hybrid. Determination of empirical resonance energy. Four types of thermochemical determination methods are used for the determination of empirical resonance energy. First is heat of combustion. Second is heat of formation. Third is heat of hydrogenation. Fourth is energy of hydrogen transfer reaction. First is about heat of combustion. It is an example of heat of a specified type of reaction, combustion. It refers to the heat released in complete combustion of 1 mole of substance in oxygen. The energy change associated with the combustion reaction of heterocyclic compound pyridine is heat of combustion can be determined by calorimetry. So this is all about energetic criteria in aromatic heterocycles. Thank you.